All right, in this video, we're going to go ahead and cover section 1.7, transformations of functions, still part of unit 1. This should be a nice, easy video. It's a lot of review. We have some things you need to copy first. We have vertical and horizontal shifts where we let c be a positive real number, okay, and f of x be a function. In other words, c is just a positive number on the real number line, okay? So we have 4 different things that could happen here. We have, let me focus this a bit. We have that a vertical shift can happen c units up. So if we want the graph to move up, what we do is we just add that number at the end of the function, okay? Same thing with the units down, but now we're going to go ahead and subtract that number, whatever it is. If we wanted it to move down 5 units, for example, we would say our function and then minus 5. If we're going left and right, okay, so, or backwards, right or left, what we do is we actually subtract the number for right and we add the number for left. And the reason this works is because we're actually doing x minus the whatever number it is. So if it was actually a negative number here, it'd be like x minus negative 5 or whatever, and that would just turn into a positive. If that's too complicated, just think of it as opposites, okay? So anytime you're dealing with x, so if it's inside the parentheses, think opposite. We're going to go right into an example because this is kind of review. We have use f of x equals x cubed to sketch the graph of, and then we have 2 different examples here. So go ahead and write them down. Something to take note of is that these functions are based on 1.6. So those parent functions that you learned about then, you do kind of have to be a little bit familiar with them. You need to know more or less what they look like, okay? Because that'll kind of help you decide what the graph's going to look like for one and where to move it. So we have g of x is equal to x cubed plus 2, okay? So what this means is that we're going to take this function, we're going to move this 2 units up because plus 2 falls under right here, plus something. So it would be 2 units up. So before I even attempt the graph, I'm going to go ahead and put that transformation right here. I'm going to go ahead and write down it's a vertical shift, okay, 2 units up. So we do want to know, identify what it does verbally. So verbally, it's that it's going to move up by 2 units. I'm going to go ahead and show you the graph that I already kind of drew here. Okay. And I just did one graph, but we can put, but well, we can make another one over here for this one. That's fine. So this graph that we see here, this is actually our original function. I like to call it the OG, standing for original graph. Okay. This is the original graph for this particular type of function. There it is, x cubed. So in case you forgot, there it is. Notice that I also went ahead and labeled 3 points just so we kind of have a reference on how we're going to move the graph. Okay. So for g of x, I'm going to go ahead and color code a little bit. For g of x equals x cubed plus 2. We're going to take all these points and move them up by 2 units. So 1, 2. There's 1 point. 1, 2. Another, 1, 2, and another. And then from here, I can just kind of sketch what it's going to look like. It doesn't have to be perfect. This is just a sketch. So as long as you have, you know, 2, 3 points or so, you're fine. Normally, we try to go for the origin, okay? And that is it for this one, okay? I'm going to add one more thing at the bottom because you're going to have to know this. So on here on the bottom, I want you to write the words function notation. Okay. And what function notation is we're going to use f of x instead of writing that whole x cubed plus 2. So just as a reminder, so we don't have to go back up to the paper, this is what we had up there. Okay. And we also know that f of x is equal to x cubed. So this is just, I'm just rewriting it. It's what we had up here. So function notation would be g of x. So this one, the new guy, is equal to all of this, but we want to write it in terms of f of x. So all that we do is we replace x cubed, we replace this part with f of x. and then add the 2 at the end. So all you're really doing is plugging in, okay? Wherever you see that x cubed, plug it in with f of x. And this is our function notation for this transformation. And we're going to see examples that are written in this format in a little bit, okay? So I'm going to jump to part B now and move this over just a little bit. So we have h of x is equal to x plus 2 cubed minus 1. So this one has two transformations, okay? It has a 2 on the inside and a 1 on the outside. So I'm going to put the one that I already know because we just did one like it. We have a vertical shift 1 units down. Okay, that's one of them. That's this one right here. Okay, and then we have 2 units, so we have something else going on in here. So if you forgot what this is, just go up here and you see that it's in this one. So that would be a horizontal movement. Okay, so I'm going to go ahead and write that down. Horizontal. Okay, uh, 2 units. And this is where it gets a little bit tricky, okay? So remember that if it's plus, you're thinking the opposite, so it's actually going to go left. Okay, so we're going to do the same thing. We're going to go ahead and plot our OG first. Remember that the OG is our original graph, not the other thing, whatever that thing is. So 1, 2, 3, 4. I'm just making a pretty standard graph right now. For your assignment, I would like you to go ahead and do this parent function graph, just so I can see the comparison, okay? So again, our OG is centered here in the middle, and I'm just kind of dashing mine a little bit. Okay, so there it is. This is f of x, which is x cubed, our OG, okay? And I'm going to go ahead and do these transformations. So from these 3 points that I have here, I'm going to move down 1 unit and then 2 to the left. So down 1 unit and then 2 to the left. There's that point. Down 1 unit, 2 to the left, and then down 1 unit, 2 to the left. So my new graph is something like this. And this would be h of x in this one. Okay. Finally, I'm going to go ahead and do the same thing like on the other side and do my function notation here. So we're going to start off with h of x this time because that's the name of this one. And I'm going to go ahead and put my f of x. So be careful. Let me put this here on the bottom just as a reminder. Remember, this is f of x. Be careful because in this one, we actually have the inside part, the x is replaced by x plus 2. So when we rewrite it, we have to do it like this, x plus 2, and then the minus 1 is on the outside. Okay, so essentially, in case we forgot what h of x was, here it is. Remember, I'm just rewriting this part for you. Cubed. So essentially, how we do this is we plug in, oh, sorry, we plug in this piece into here, and that's what we have here. Okay, this part right there, and then the 1 just goes on the side. And you'll get the hang of these. The function notation is not that hard at all. But yeah, that's pretty much it for these two examples. Okay, let's go ahead and move on. More stuff to copy, and I really do hope this is mostly review for you all. So here we have reflecting graphs, and what we're going to do is we're going to flip the graph either over the x-axis or the y-axis. So this is what they're defined by. Reflection on the x-axis, okay, so you're thinking like, you're thinking a flip this way, okay, is going to be h of x is equal to negative f of x. So what you do is you flip over you flip the y values, okay. So I'll put like a little example here on the side if you want. So an example of this kind of symmetry, okay, would be something like, there's our OG. This would be the new one. It flips over the x-axis, okay. Reflection on the y-axis, okay. There's our OG, and that one flips that way. And all you do is change the opposite values, just like we did with even an odd symmetry, or not symmetry, when we're doing symmetry over the x and y, where we change the values. It's the same concept, okay? So let's go ahead and look at some examples. We have example number 2, and I'll go ahead and scroll up in a little bit for this part. We have if f of x is equal to x squared. Okay, so this is the square function or quadratic if you prefer. We're going to sketch these two guys. Okay, so just like before, we're going to go ahead and identify what's happening first. Okay, this one actually has two. Okay, um, for letter A, let me focus on letter A first. We have a negative on the inside. Okay, so that means that we're going to have, according to my little notes here, we're going to have this happen where the x is negative, so it's reflection in the y-axis. So I'm going to go ahead and write that down. Reflection, I'm going to say over just because I prefer that word, over y-axis. Okay, so you can see here, so this is the transformation. Okay, you can see here on the graph that I went ahead and drew our OG. Remember, our OG is f of x, which is in this case x squared. And these are my 3 points that I picked. Notice I do tend to pick the ones really close to the origin just because they're easier to manipulate. Okay. And if I'm going to flip over over the y-axis, what's going to happen here is that this point right here is going to land over here, and this point is going to land over here. So in this case, this graph is actually the exact same. And the reason that is so is because this graph has even symmetry. Remember that even symmetry is when the graph is perfectly mirrored on both sides like so, and reflects over the y-axis. So this one is going to be our h of x, and it's the same since f of x, which is our x squared, is even. So by definition, over the y-axis, that's our even symmetry right there. Okay, lucky for us. Just like the one before, I'm going to go ahead and have us do the function notation. So I'll do that right here. So function, ignore this problem down here. Okay, no, don't look at that yet. Function notation. So we start with our new function, h of x. Okay, and we're going to write our f of x, but in terms of whatever's going on here. So it looks like all that we did is we just made x negative. So that's it. Next one. Let me get this a little bit straighter. All right, so for this one, we have two different things going on. Okay, we have, here, let me do that so it's not so distracting over here. So we have two different things going on here. We have this negative, and we also have a 1. So the 1 on the inside, we should know from the page before that this is just going to be a horizontal translation, okay, or shift, whichever word you prefer, to the left. So I'm going to go ahead and do that one first. So write that out. Oh, sorry, I don't know where I'm getting that 2 from. 1 units left. Okay, so that's this part right here, the little +1. And then the negative here in the front, that's the new one that we sort of kind of learned. This is the negative coming from here, the negative in front of the function. So it'll be usually in front of the parentheses or absolute value or whatever this is, it'll be in the front. So for that one, I'm going to have reflection over x-axis. Okay, so that's this one. So just like the one before, we have our parent function, our OG here for x squared. And I have my 3 points. I'm going to go ahead and do whatever this is telling me to do. Now, some people, they like to start with, whatever's first. You can do whatever you want at this point first. I'm going to go ahead and flip first and then do this. So reflection over the x-axis would be this point right here would jump over here. So I'm going to have kind of like, and if you want, I can color code it. We can do it in steps if you want. Seems to help some people. So we can do the flip first. So this would be our flip. Okay, so just the reflection would be this guy. Okay, now if I'm going to move 1 unit to the left, okay, from here I can go ahead and do that step next. So from here I'm going to move this one over here, this one over here, and this guy over here. And this is what I'm looking for. So if you need to do it in steps, that is perfectly fine. If you can do it all in one step, then good for you. Okay, some of us are a little more visual. So this would be my new function h of x. Okay, and then last but not least, our function notation, I'm going to try to squeeze it in here at the bottom, is going to be, okay, h of x is equal to, and we want to write it in terms of f, so it would be negative f parentheses x plus 1. Because all I'm doing is replacing the inside with the inside. The negative comes out here. Some people ask, do I have to put the square still because this one has a square? Well, you don't, because remember that f of x was from the very beginning defined as x squared. So you're just replacing this with this, okay? All right, so I'm gonna go ahead and move down to the next example, and I think we're already more than halfway done, so hopefully this video is not too long. Example number 3 is writing equations from a graph. So this graph is actually a little bit different. We haven't seen this graph yet. It is a polynomial of degree 4. Okay, so what that means is we have a little exponent of 4. Okay, and the cool thing about this one is it kind of looks like a parabola, but once we start adding numbers to it, it starts doing like loops and stuff. Since this is just x to the fourth, what happens is it's like a flattened out parabola. Okay, it looks like this. Okay, so you'll just have to trust me. If you don't, you're welcome to graph it and check. Okay, so this one is saying, given this parent function, so they just decided to pick one. Okay, write the equation for the other guy. Okay, so this is going to work very similar to x squared, except instead of a square, it's a 4. Okay, so what I'm going to do is I'm going to look at the pink one now and see what happened. What are the transformations that happened from my OG to the new function? Well, I can tell right away that it reflected, like it flipped over something, right? So I'm going to go ahead and put that here. I'm just going to put reflect. It reflected over this way. So it went from the top to the bottom. So that's going to be over the x-axis. So over x-axis, okay? And remember that over the x-axis is negative f of x according to my notes on the top. And then it looks like it went from the center up by 1 unit. So I'm just going to put up 1 because of the room here. Okay, so it went up by 1, which also according to my notes up there means f of x plus 1 in this case. So all I'm going to do is I'm going to take these two things and put them into this function. So let me rewrite it a little bit. First, I'm going to write it in function notation. Okay, so function notation would be negative f of x and then plus 1. And that's one way you could define this. But if I want the specific equation, then I could say, well, h of x is going to be equal to negative f of x is equal to x to the fourth. So I'm going to put x to the fourth and then plus 1. And that is it for this one. If I can get this one to fit over here. Okay, for this example, we have not only did it flip, but it also moved over in the right direction this time. Okay, so what that means is I'm going to go ahead and have another reflect. I'm going to put it over here. It's also over the x-axis. So I'm going to just put over x because I'm out of room. And then it went, how many units? Let's see. 1, 2, 3 units. 3 units right. So without having to write too much information here, okay, h of x, okay, is going to be equal to, remember this is the same as this guy right here, so it's going to be negative f of x, but since we went 3 units to the right, remember that the left and the right are inside the parentheses, so I have to put that 3 in here somewhere, okay? And also remember that when we're going left and right, it's always the opposite of what you think. So instead of it being plus, it's going to be a minus. And that would be it for this part right here. If I wanted to write it as an actual function, it would be h of x is equal to negative, and then my function was x to the fourth, so I do have to put this part in parentheses, like so. Okay, and that is it for this one.